Howdy. Today we're introducing Windows Server 2016, an amazing new release. This release is dramatically different than previous releases. In previous releases, it was all about the server, but there's this cloud wave and that's changing everything. Customers have asked us to help them in three specific areas. They want us to help them address security threats, they want help with data center costs, and they want to have help with driving their business forward with application innovation. Today, you're going to see how Windows Server 2016 delivers amazing modernization in each of those three areas. And joining me today are these rock stars. I've got Aaron Chappell, Partner Director of Program Manager. Aaron is the product owner of Windows Server 2016. And of course, you all know Jeff Woolsey, superstar Jeff Woolsey, Principal PM
in Windows Server.
In Windows Server. So let's provide some context, right? So really talk about the 20 years of Windows Server. So let's provide a little context. With Windows Server NT, we took Dave Cutler's awesome kernel, we put a desktop experience on it, and we ran it on PC class hardware. This transformed the world. Prior to this, servers were a thing of the high priests and the princes of technology. They were the only ones that could run servers. But with this combination, now we had server for the masses. Now anyone could buy, deploy, and operate their own server. This was transformed the world. There were so many of those and so many clients, it brought about the next era of the server, and that is the enterprise era. With Windows Server 2000, we introduced Active Directory and group policy, and now you could tie all these things together in a coherent way. And that was the enterprise era. Then, with Windows 2003, we got .NET. And with .NET, we got the LOB revolution. Now everyone could write their own mission-critical line of business applications running on Windows Server. That forced us to enter the data center era. Now the data center era was a big transformation. We had scale up, we had scale out, did a great amount of work in virtualization, and the management model changed from GUIs in the local GUIs and server for the masses, remote desktop in the enterprise era. In the data center era, we got PowerShell, and we want to be able to automate all the things in the environment. This then led to the cloud, right? Windows Server 2012. Now, both 2008 and 2012, these were the server technologies that Azure used to build the cloud. And now what you're seeing is we're taking those technologies from Azure and we're bringing them and delivering them to you in Windows Server 2016. Now here's the reason why I point this chronology out, and that is that Windows Server 2016, while we've made great advances in the cloud, it continues to be an awesome server for each of these other areas. It is an awesome data center server. Continue to invest in that. It is an awesome enterprise server, and if you want to have a single machine with a keyboard, a mouse, and a touchscreen monitor, it is an awesome server for the masses. Indeed, you'll be able to walk up to that machine and say, "Hey Cortana, start IIS." It is a great server for the masses. Now, of course, System Center is really the management technology that allows us to tie this all together and deliver a coherent, integrated solution. So these things working together. So Aaron, you've been talking a lot to customers. Why don't you tell us a little bit about what they've been saying?
Yeah, so Jeffrey, as you were talking, we really are at this big inflection point in terms of just the technology and what we're trying to do with the server. And so when we were starting at the beginning of the Windows Server 2016 planning era, we really went out and we started engaged a really good cohort or a set of customers that really became our trusted partners as we went through the life cycle of planning Windows Server 2016. And they were really, at this inflection point themselves. They were really looking at the changing demands of the business and how they needed to improve the agility. Today, even if you are a retail organization or you're a medical organization, really you're a technology company. With the rise of the cloud and the rise of mobile applications, we really need to deliver those to our end customers. And so they were really looking at the cloud and seeing the benefits of the public cloud, but not really sure how to make that transition, and concerned about security, concerned about compliance, about their data, and really looking at how do I invest in a way that's really going to future-proof me and set me up to be able to take advantage not only of what I want to do today within my data center, but the power of the cloud moving forward. And so we heard from customers that hybrid cloud was really their strategic direction, right? They're all in on hybrid cloud. They really wanted this ability to not only invest in their local their data center within their organization, but also be able to consume public cloud offerings or hosted cloud offerings as they see fit. And so, really, the answer is, seriously, is there any other answer than investing in the hybrid cloud? And so when you look at it, all of these things coming together, though, they really provide a pressure point on the organizations, particularly on IT. IT is really being, pressured to have secure, controlled IT resources, right? All of those old eras of the power of the enterprise server, the data center, the fact that I can lock it down, I can have control over it, I can manage my costs, I can control security. That all doesn't go away in this new era. As you said, it's really kind of additive. And yet, as I was talking about, the business agility and innovation that is coming is at an unprecedented rate for these customers. If I think about it, and I, 10 years ago or even 5 years ago, if I wanted to do, if I wanted to go on an air flight, it really was a very manual process, right? I would call a ticket agent, I would get my ticket, I would show up at the airport. But now most airlines actually have mobile applications. I was taking a flight just yesterday, and I could purchase, in-flight meal options as part of that. And so that demanding agility that you need to have really, creates pressures on the IT organization in particular and the development environment within that organization.
I heard one CIO of an airline said that they were a software company with airplanes.
Yeah. And I think that that's the case not just in airlines today, but in retail, in medical, and all of these other different fields. So if you think about it, by the year 2017, 50% of the total IT spending will be spent outside of the formal IT organization. And so you've got this real, kind of pressure happening within the organization, within that system, that puts demands on what the infrastructure is and what the infrastructure investment and what you need out of a server, right? Servers really changed in what you provide today versus what you provided in the last decade. Mm-hmm. And so this really leads us into, three key investment areas or kind of pain points that IT organizations face today that we want to invest in. The first is around security threats and really being able to provide the assurance to the company that their assets are protected, right? That that the OS is secure, that they can have controlled secure access to it, and that they can really be confident that what they're running is not going to lead to them being on the front page of the news. The second key threat is really around the data center efficiency. Again, as we have more and more demands being placed on that back-end infrastructure, and the power or the promise of the cloud is really to be able to abstract that underlying infrastructure and be able to run that and provide those services to other businesses within the IT or within the company. Then really you want to be able to run that at a very high efficient, low kind of total cost of ownership. And so there's a bunch of investments we've made in Windows Server 2016 around that. And lastly, it really is around supporting this innovation and this business agility. Really in this world, you were talking about the airline company being a software company now. The developers within that organization are really key and core to providing that service and contributing to the bottom line. And so it becomes really important for us to support that DevOps cycle and really be able to, reduce the complexity of building applications, deploying them into the environment, and then the ongoing management and operations of those. And so, over the course of the next, 40 minutes to an hour or so, we're going to spend time kind of going into each of these areas, and Jeff will be helping us kind of get into the depths of the investments that we've made in each of these areas. So let's start off around security threats. I don't think I need to, say, I was actually coming in this morning, I was listening to, NPR, and we had, there was an article about how just the importance of security and threats in the banking industry. And that's just one of the many industries that really, care about this. But, security and cyber threats are a material risk to businesses today. If you think about just the lost productivity and growth, the brand image that can result from a data breach, or just the liability at the end of the day if you should kind of lose sensitive information, sensitive customer information. This is a material risk to businesses. And so with Windows Server 2016, we've really put in the layers of security to be able to protect you against some of the emerging threats that we're seeing. And really this comes down to how do we shorten the amount of time between when an malicious, kind of person gets into your environment, and when we know that that's the case, and that we can, have taken steps to remediate that. If you take a look at the research out there, really the timeline is interesting. You start off, and these malicious attackers are really kind of lurking in the background, and they're trying to collect as much information as they can, and they're researching and figuring out what the right attack vector is. And then from the time that the first host is compromised, it really is only between 24 and 48 hours between that and when the domain admin is compromised. And at that point in time, they've got the keys to the kingdom, right? And so, that largely then goes undetected, and on average, it's more than 200 days, right? That's almost over half a year that they're going in, and they really, have access to whatever, they're looking at.
Secrets, business plans,
Data,
pricing.
Yes.
Exactly.
Yes.
And so it really is then about how do we then, help bring that forward and then give you ways in which you can mitigate against that.
I have to say this is one of the things I'm most excited about. In the past we were always very committed to security, and there's always a lot about hardening the system, protecting the system. And here we've made, as you'll see, great contributions to that as well, additional investments, but we've taken a more mature approach, and we say, hey, if somebody gets in, how do we assume breach? How do we protect the environment from that? How do we interrupt those attacks? How do we detect them? How do we remediate them? That's very exciting.
And how do we keep them from expanding and going throughout your infrastructure? And it's funny, when I look at this attack timeline, we say research and preparation, but at the end of the day, there's really two things that attackers have at their disposal that make them super, super dangerous. Number one, a search engine, and number two, human nature. Because the way they're attacking people now isn't through the network, how we traditionally think about people, attacking through the firewall and things like that. It's identity. And if I can find, just an org chart with the names of people in a sensitive organization, and if I can find, not the CEO or the CTO or the CIO, but some people that work for them, and just send them a phishing attack, I can do all sorts of damage, and that's how they make their way through the company, and they're able to go undetected. And so there's a bunch of work that we've done to actually help prevent these attacks.
That's a great segue into kind of really this layered approach that we're taking from a security threat point of view. The root of it is really about protecting identity, right? Because once you have that access and you have that person's credentials, you can really act on their behalf within the system and gain access to whatever it is that they would have access to during a normal course of business day.
When I talk to people, a lot of people wonder, well, how is it possible that they can go 200 days before being detected? And that's exactly it. Once they get in, they look like a normal person. They're doing legitimate things illegitimately.
Yeah. So that's kind of the first level of investment that we have. The next is then just protecting the OS as it stands, right? That is what is running on the fabric, what is running on the base, metal, and as well as in the virtual machines in your environment, and really making sure that can be trusted, and that is, running the things that you want it to run and not running things that you don't want it to run. And then lastly, in this move to the cloud, right? It really, with virtual machines and as well with containers, you really are running in a different configuration than you've done in the past, particularly in a case where you might not actually own the fabric that you're running on top of, right? I might be trusting either, a hoster or somebody, even the different department in my IT organization, to be running that fabric. And so making sure that you are securing those virtual machines and you know that they're running on the fabric you want them to run on, and that you're protecting them from the underlying fabric administrator is super important as well. And so with that, let's kind of look into each of these areas. I'm going to hand it off to Jeff to really start to talk about identity as the first step.
Thank you. Yeah, identity is is critical. Like I was mentioning earlier, we used to think of the attack vector as really the network firewall. If you looked at a bunch of bad movies in the 90s, they would always talk about, oh, we've got to breach the firewall, and once we get through there, we'll get inside their company and we'll take it over.
Those were great movies.
Those were great movies, right? They were always doing amazing things through a 56K modem. But what's really changed is, yes, the folks are still attacking that way, but there's much easier ways to do it. It's through phishing attacks. It is literally, if I can get an org chart, if I can find some people in an organization, I can send an email to a number of people within an organization that looks real enough that I can get them to click on something that allows me to get some malware installed on their machine. Now, all of a sudden, I can seek out and leverage administrative credentials. It's an attack that's called pass the hash. And so we've been working very hard to protect and mitigates these completely. The other challenge we see is that administrative credentials are often provide far more privilege than necessary. So, for example, if I'm Jeff, the network admin, and I typically need to make changes on the network firewall, sure, I should be able to do that. But if I'm logged into my system and I'm just typing up email or browsing the web, I shouldn't be logged in as Jeff, network admin. Now, we all know best practices, and we all know, all the admins will say, oh yeah, we never do that, but we all know that they are doing that. And what you really want to do is you want a way to actually enforce that and say, you know what, 99% of the time when I'm doing most of my regular work, I am just logged in as standard user, and when I need to go get my privilege elevated to make some changes on the network firewall, I can do that. So we're introducing a number of new technologies here to solve and mitigate a number of these types of issues and attack vectors. Credential Guard. So prevents pass the hash and pass the ticket attacks. Quite honestly, we could spend an hour, Jeffrey and Aaron, probably just talking about this alone. But at the end of the day, when people are logging into systems, they may leave some trails behind them that allow me to get stored credentials and allows me to impersonate users. And if I can somehow get a domain admin to log into one of those machines, or who has logged in for whatever purpose, perhaps I can use those credentials to elevate my privilege, and all of a sudden I go from being standard user to a full domain admin, which allows me to now drop all sorts of malicious software inside your infrastructure, and you'll never even know I was there because I look like someone who should be there. Remote Credential Guard also means that if I'm logging in remotely, we're also mitigating that, also those pass the hash and pass the ticket attack vectors. So this is actual capabilities that's built in the Windows 10 Anniversary Update, as well as in the Windows Server 2016. These are just fantastic new capabilities that just literally mitigate these issues straight up. Then we have just enough administration and just-in-time administration. And just enough administration, I have to admit, Jeffrey, this is probably a little bit in your wheelhouse, because we're leveraging PowerShell in a very big well here.
Yeah, exactly. So the idea with just enough administration is just enough administration. So the idea is that you don't have admin privileges, you're just a regular user. And then when you connect to a machine, it determines what things you should have rights to, and it'll generate a temporary elevated account, an admin account as you, and then gives you access to just those set of actions, right? Just SQL management or just AD management. And so you're admin to do those things and then nothing else.
I was talking with a recent company, an enterprise company that came in, and he said to me, Jeff, what we're looking for is a way to guardrail new administrators. Right. I have my IT pros that have worked with me for 10, 20 years. I trust these folks. They've been well trained. They know our systems. I'm getting some new college hires. They're really smart. They're really bright. It's not that I don't trust them. It's just that they don't have the years of experience. Are there ways that I could guardrail those admin privileges? So, for example, he could be a SQL DB admin, but that's literally all he can do. He's still an admin in the eyes of the organization, but he can't traverse the file system or go look at my mail servers or go look at all my file servers. And this is a way to say, you know what, you are still an admin, but you can only see the things that you need to be a SQL DB admin.
That's exactly what JIA does.
Yeah.
And then there's JIT. JIT basically says, hey, you know, if you're supposed to be on vacation, your token can't be used for admin privileges. So the idea is that, again, you're just a regular user, and then at various times you'll be elevated to an admin rights, and then you get a very short ticket. user gets to define, whether it's, and here we encourage people to, do something that's practical and then refine it. So just say, configure it so that only during your work hours can you be an admin. And then you want to be a little bit more fine to say, hey, when you were working on which systems, you get a token for that period of time, and then it expires.
Perfect. And of course, all of this is completely audited. So if we need to go back, we can see exactly who made changes and when.
Yeah, we made a lot of investments in the auditing because we looked at people doing big data analysis, trying to find the bad guys, and we was like, oh, well, we're missing some events here. So we don't talk about that as a big feature, but we actually did a lot of investment in that to make it easier to highlight the patterns of the bad guy, kind of added a slime trail.
Awesome. So I love this because for once, we basically raised the bar. We're adding additional layers of security to help protect admins. Yep. In the past, we've always kind of said, well, if you want to limit your users, just make sure they're users. But for admins, we were kind of assuming, hey, they are going to do the right things, right? That's why you're paying them the big bucks, right?
Admins are an attack surface.
They are an attack surface.
And I think we've really taken the feedback we've gotten from customers into this, where we've done it in a way that it should really be seamless to the administrator. We've thought about what their work practice is, what their habits are, et cetera. And we've really just created a way to take those best practices and implement them in the system in a way that makes things more secure.
Exactly. Love it. So these are all about helping protect against compromised admin credentials with just enough and just-in-time administration. Next, I want to talk about some of the things that we're doing to help protect the OS. So one of the things we want to make sure people understand is we want to make sure that the OS is actively participating in your security infrastructure. We don't just want it to be something that's just a runtime. We want to make sure it's actually helping. If the bad guys somehow do figure out a way to get in, we don't know of any way right now, but if they do, we want to make sure that they can't get out. They're in a locked Faraday cage that they can't move their way out. So we have these, we want to make sure that new exploits that try to attack the OS, even ones that haven't been created yet, can't use, they're trying to use the boot path all the way up to get into applications. Well, we've done a lot of things to harden the boot path over the years. We've done a whole bunch of things to help protect the OS from attacks that we don't even exist, that don't exist yet. And we are now taking that to the next level with what we are doing in Device Guard and Windows Defender and Control Flow Guard. So Device Guard allows us to basically ensure that only permitted binaries can be executed from the moment the OS is booted. So think about it this way. If I have, for example, I have a Hyper-V server. This is my virtualization host. I want to make sure, guess what? This has only the things necessary to run Hyper-V. And most likely I'm running this with our new Nano server. I'm using Server Core. But if someone, even an admin comes by later and drops something on here because, oh, you know what, I need this to help me with some remote thing. Guess what? If it's not part of the CI policy, even if an admin adds new binaries, they won't run.
And CI policy is
it's
code integrity.
Code integrity, thank you very much. Yeah, so the code integrity policy ensures that only what we have whitelisted can run on that system. So it helps us really protect against configuration drift, but most importantly, protects another admin from installing something later that they shouldn't be running. And Device Guard actually has two different modes. There's an audit mode. So if you trust your other admins and say, okay, we'll let them install it, but you'll get notified of any changes. Or you could actually go in strict block mode. If anything gets installed, nope, it doesn't run until the code integrity policy is updated. So that's one way to really help protect the actual system itself. And then, of course, we're introducing Windows Defender to Windows Server. We've had Windows Defender in client now, but we wanted to make sure that we just made it as simple as easy for Windows Server to be deployed. And also, no matter where it's deployed, whether it's running on your premises in your private cloud, whether it's running in Azure, or whether you're running on a different virtualization render, or if you're running in a different cloud like AWS, for example, guess what? It means when Server 2016 deployed, it already is deployed with active anti-malware there with Windows Defender. So we just made that real simple, and it's in the box. And of course, if third parties prefer customers prefer to use a third party, they can always use those as well, but we wanted to make sure that simply out of the box, it was secure and ready to go.
And we also did a lot of work on this to ensure that performance works, so to ensure that it didn't have an impact on server workloads. This is pretty sweet stuff.
Yeah. Yes, very cool. And then finally, we have Control Flow Guard. I feel like we're getting really deep into the wilderness here, so I'm going to not spend too much time on this one. But the important thing to know about this is actually some security that we introduced way back in Windows 8.1 and Windows Server 2012 and 2012 R2. But what this allows us to do is protect against unknown vulnerabilities by protecting against classes of memory attacks. And what we've done now is we've now introduced that and compiled. These are compilation flags that a developer can use. Well, we made sure that, guess what, now Windows Server has all of this baked in as well. So we've added an additional layer of protection just into the OS itself to protect against memory types of attacks. And then finally, we get to probably, I have to admit, this is probably my favorite new security feature in Windows Server 2016. I've been working on hypervisors and virtualization for a long time, and one of the things I've told people since, you can probably find sessions of me talking about this in 2003, is that while I love hypervisors and I love virtualization, virtualization actually does create problems. And I know a lot of people don't like to admit this, but it's true. The first one is single point of failure. So if in the past, before virtualization, if I was running a server with just SQL and this server went down, okay, SQL went down. And sure, it was bad, but you know what? It was one workload. And that's why we introduced things like clustering and things like that to make sure it was highly available. Well, then of course we added high availability, live migration, shared nothing live migration. We added all of that to virtualization as well. So guess what? We've done a really good job mitigating that one. The second problem that virtualization has created, though, is the single point of attack, which means that once I get into a host, it's not just one server. If you have 50 or 100, or I've compromised potentially the entire virtualization fabric, which leads us to an even bigger problem, which is really all of your fabric admins typically have control to your virtualization, whether it's the host administrator, the storage administrator, or the network administrator. Anytime, if any one of these gets compromised, they can pretty much own your virtualization infrastructure.
You know, in the past, it was very hard to break in and steal an entire server, right? They're kind of heavy.
Exactly.
Whereas if you break into a VM, you can snapshot the memory and live migrate it somewhere. And here's the other thing: if someone actually did steal your server, you'd notice it.
Yes.
If somebody took a copy of your VM, you're never going to notice it.
You have no idea. Well, you're right, and that goes to another point about virtualization: is we made it really easy to steal workloads. Exactly. Because in the past, you're right, you could literally take a physical server, or you could try and copy files off a disk, but it wasn't, it was still trying to grok files. With VMs, a VM is literally a couple files. So we made it easy to just copy files off on a USB stick, walk out the door, and you have no idea that I just took some part of your infrastructure. So what we are doing is something really tremendously awesome. I'm so proud of the work here, which is shielded virtual machines. And shielded virtual machines is essentially providing a way to not only, I know we've been talking about it as a way to encrypt a VM, but it's so much more than that. It's really making a VM a black box. Once that VM is shielded, to a fabric administrator, I can run a virtual machine, but that's all I can do. I can start a virtual machine, I can stop a virtual machine, but that's it. I can't mount it, I can't inspect it, I can't look at the thumbnails, I can't get a console connection. If I steal it, if I even stick it on a USB key and I'm a storage admin and I take it home and run it on my own personal machine, guess what? It's an encrypted blob. I still can't do anything with it. This is really industry-leading technology with shielded virtual machines. And there's a number of technologies that go along with it, like the Host Guardian service, and it also capitalizes on the work that we've done in Generation 2 virtual machines that we introduced back in Server 2012. But at the end of the day, what this means is we're delivering a whole new world of protection for virtualization that doesn't exist on any platform in the world, quite simply.
Yeah, this is a game changer.
This is truly a game changer.
And it's not only a game changer. I know a lot of people who may have heard this before. We talk about it oftentimes in the context of a hosting environment, right? Where you're running, you as a tenant are bringing your own virtual machine and you're running it on somebody else's fabric. It's also a game changer within the enterprise, right? For all of these reasons we've talked about of really wanting to be able to limit, if an attacker comes in, where they can get to, by implementing, shielded VMs in your internal environment, things like Active Directory, right, where people have been hesitant to virtualize that in the past.
Oh, yeah.
You know, given the fact that, you know, it is just a VHD sitting on the disk. If I can inspect that, I can mount it, I can actually then gain access to, you know, my secrets within my Active Directory. You know, this also then provides you with that defense in depth in some sense within your organization. And so when we talk to customers, this is, you know, the security features as a whole, but particularly shielded VMs, is one of the things where they're like, you know, I am really looking to deploy Windows Server 2016, you know, at a faster rate within my organization than I have with previous versions of the OS, just because of, you know, the importance of this area and the assurance that it can provide me with my organization.
Yeah, let's be super clear here. If you have a mission critical workload, your domain controller, your PKI servers, your cert servers, all of these things, there's absolutely no better way to run it than virtualize using a shielded virtual machine. And just very quickly at a high level, to explain how this works is essentially a virtual machine. When I log into a virtual machine as the admin of the VM, not the infrastructure, not the Hyper-V host, but it will actually ask the key protection that's running in the host guardian service, and can I have some keys? Can I actually have the ability to run the shielded virtual machine? The guardian service is actually running in a separate domain. It's a separate domain of the infrastructure, and what it's actually doing is a number of very important things. Number one, it actually attests to the fabric. So it makes sure that when a Hyper-V server, a server running Hyper-V, when it booted up, it actually went through the boot process, it actually tested and attested and measured the boot process. When it actually booted, it then checked the code integrity policy. Are you running only things that are allowed via the code integrity policy? Does the code integrity policy pass? And then finally, we can also look for things like debuggers. If we see a debugger on one of these, we know that perhaps someone's trying to do something they shouldn't be, like trying to inspect memory or something like that. And we say, sorry, this doesn't pass the test. If it doesn't pass the test, then the shielded VM cannot start on that server. It can only start on the server once the host guardian service has said, yes, this passes our tests, on our measurements and our code integrity policy, yes, this shielded virtual machine can run. Because it says, yes, I look at you and you look healthy. So with that, enough slides. Let me show you and give you a demo of shielded virtual machines. Awesome. With virtual machines, we encapsulate the operating system, apps, and data in just a few files, making them easy to move and live migrate. Unfortunately, that encapsulation also makes it easy to steal virtual machines and mine them, looking for credit card numbers, names and passwords, or other secrets. In addition, the virtualization fabric itself, controlled by virtualization admins, network admins, and storage admins, is a large attack vector and one that the entire industry has no answer for, no matter what virtualization platform you use: Hyper-V, VMware, KVM, or Xen. Let's take a look. I'm logged in as a malicious SAN administrator. And let's keep in mind, I could be literally a bad guy who somehow has gotten secrets like credentials, or I could be someone actually internally who's had a bad performance review and maybe leaving the company and wants to do something malicious. In any case, the motivation doesn't matter. The important thing to understand is I'm a SAN administrator with full SAN admin creds. And my goal is to steal secrets like names and passwords, for example, out of an Active Directory database. Now, I know the domain controller is virtualized and likely on the storage fabric, so I'm going to browse the SAN. And in fact, I'm going to go to the virtual disks folder, and I'm going to take a look inside here. And lo and behold, it's a treasure trove. I found Active Directory domain controllers 1 and 2. So I'm now going to perform an extremely complex attack against this virtualized domain controller. It's called a double click. Now, by double clicking it, I've actually mounted the virtual disk and I can see the file system, including the NTDS folder and the ntds.dit file. This, in fact, is the entire Active Directory database. I can now copy this, go on over here to my USB stick, paste it over here, and in fact, I can take it home with me, and now I can spend the next few months brute force attacking it, trying to actually get the secrets out of it. When I do, I'll have something that looks like this. In fact, here you can see I've got a key value pair list of usernames and passwords. The point I want to make here is that any virtualization fabric is susceptible to malicious attacks from admins. Well, wouldn't it be great if you could protect VMs from Fabric administrators? That's why we're introducing Shielded Virtual Machines in Windows Server 2016. Shielded VMs are a black box to Fabric admins and are controlled by the admin of the guest OS. So let's take a look at that. Let's bring up System Center Virtual Machine Manager. In fact, we're going to convert that existing domain controller to a shielded VM. In fact, you can see here I've got my DC2 has actually already been shielded. We'll get to that one in just a minute. But in fact, here's the one. You can see Secure Boot is enabled, but we haven't shielded it. To do that, we're going to click on the Shield button, and we are going to add shielding data. So this begs the question, of course, what is shielding data? Well, shielding data is an encrypted lump of secrets that is created by the virtual machine owner. It securely delivers secrets to the fabric on which the shielded virtual machine will run. Those secrets include the administrator password, a list of the fabrics on which the shielded virtual machine is authorized to run, an RDP certificate to ensure you're connecting to the virtual machine that you deployed, and a volume signature catalog that ensures the integrity of the template disk when deploying new shielded virtual machines. Now, while it takes a few minutes to go ahead and turn this VM into a black box, we're going to perform this same attack that we just performed, this time on a shielded VM. So we're going to go back to our SAN, and we're going to go back into the virtual disks folder. This time we're going to attack the shielded one, which is Active Directory Domain Controller 2. Again, I'm going to perform the same very complex attack. We're going to double click on it. And in fact, you'll see it says, sorry, this drive is BitLocker protected. All right, well, let's go up to Explorer. And in fact, you can see here, it is in fact BitLocker protected. And if I try and double click on it here, you'll see I actually get a slightly different error. This one tells me there are no supported protectors on this drive. This drive cannot be unlocked. What this is actually telling me is I can't decrypt the key to decrypt the volume, even as a full admin on this machine. So I'm out of luck. All right, well, let's try another path. Let's actually head on over to Hyper-V Manager and let's try and attack this directly. Now, as you probably are aware, in Hyper-V, when you have a virtual machine that's running, you can see down here that we have a live thumbnail. And in fact, if I double click on that, it'll actually bring up a console connection so that I can actually get into the virtual machine and start manipulating it directly. So here I am bringing up my SQL Server and bringing up a virtual machine connection. Now, this is what happens when, of course, when you're using a normal virtual machine that hasn't been shielded. Well, what happens when you go to a shielded virtual machine such as this Active Directory Domain Controller 2? Well, you'll notice, first of all, right off the bat, that in fact the thumbnail is grayed out. And when I try to connect to it directly through a console connection, it says, I'm sorry, you can't do that. You have to use a remote desktop connection as well. Oh, all right, so that's also locked out here as well. So think about these things. We've actually locked it out from a console connection, and we've also locked out other connections. A couple things to think about with shielded virtual machines. Shielded virtual machines each have a virtual TPM. The TPM is used to securely seal the key that encrypts the shielded virtual machine's disks. Each shielded virtual machine has a unique virtual TPM. This ensures each shielded virtual machine has a unique encryption key, so there's no sharing of keys. Shielded virtual machines run as protected processes and will only run on known, healthy Hyper-V hosts. This ensures you can't attach other processes like debuggers, and you can't inspect memory. And finally, as you can see here, shielded virtual machines disable host integration. This means things like VM console connections, thumbnails, PowerShell Direct, and integration components like File Copy and others are disabled. In short, a shielded VM is a black box as far as the Fabric admins are concerned, and that means storage, networking, and host admins. This is how you do end-to-end virtualization security. Windows Server 2016 shielded VMs, the only way to protect virtual machines from Fabric administrators.
Awesome. Well, I think that just kind of showed very easily why this is one of the killer features within Windows Server 2016.
Very powerful
So
technology.
very powerful. So with that, let's move into our second section or second area of pain point that we really hear from customers, and it's all around data center efficiency. And this spans the gambit, within the organization, from the CFO who's really looking at how do I make my IT more efficient, right? How do I get the most out of the dollars that I'm spending in this area? And what is the compliance report around this? In the world that we live in today, you really need to make sure that you're adhering to the regulations and whatnot that exist around compliance. The CIO is really, security, as we talked about, is front and center in their mind. But then, ultimately, it's the bottom line, right? If I am in this world where I am a software company, and I'm really trying to have that relationship with my end users, whoever they, might be, and provide the best experience for them and stay connected with them, then I really want my IT and my infrastructure to be supporting, the motion of what I'm doing or what my core business is. And lastly, developers. We talked about the developers and them really being kind of key in this equation and in this new, world that we live in. And really for them, it's about how can I be faster, right? How can I get my application out into deployment in a quicker way? And how do I make sure that it runs in the way that I intended it to run? And that I'm reducing kind of the ongoing overall management costs. And so really, the data center, the infrastructure that we're providing is really core and key to this, solving this equation for the organization. And so in data center efficiency, it really is around kind of the three big pillars, right, of the fabric. Delivering enterprise class virtualization and really building on what we've been doing in Windows Server, 2012 R2, and extending that and improving Hyper-V, in addition to kind of adding the shielded VMs work around it that we put in. The investments that we're making in software-defined storage, right? And how do we enable customers to really take, commodity level, attach storage directly to their servers and run that in a highly reliable, highly available, cost-effective way. And then lastly, software-defined networking. And software-defined networking is kind of, in some sense, I think a little bit of the sleeper feature in Windows Server 2016. But when I think about that developer and I think about wanting to have portability of my workloads and portability of my applications, on premises, but as we talk about things like Azure Stack in the future and whatnot, also then bringing those applications to the cloud, software-defined networking is a critical component that really enables that. And so these three pieces, the virtualization investments, the storage investments, and the networking investments really, provide the foundation of what we do from a data center efficiency point of view.
And what really helped us in this area was running Azure.
Yeah.
When you run very large data centers and lots of them, you need to have great data center efficiency because that's the difference between making money and not making money.
Yeah, and there also is innovation that we've done in Windows Server 2016 in addition to what comes into Azure, right? We really had the best of both worlds. Mm-hmm. We've taken the learnings that we have with Azure of what it takes to run at that scale, but we also know that our typical customer is not going to roll in a rack of 40 servers, right, one at a time. And so we really need to take those learnings and adapt them to technology that works, right, at the scale and the reliability and the design point that enterprises and hosting providers need.
Yeah, and no other company's doing that.
Yeah.
No, and when I talk to customers about what we're doing in Azure, and they talk about, I'd like to see more and more of those services brought on premises, and I have to explain to them scale. When we talk about Azure, when we talk about a stamp, we're thinking ballpark 1,000 servers. We don't think a rack or a half rack or even a couple racks. And when I start to put those numbers in their mind, then they start to understand, oh, you're working at a completely different scale than I am. And so, but it is interesting because we are able to take things that we've learned from Azure, as well as take things from server and take those to Azure. The first one is actually a perfect example of that, Hyper-V. And when you look at Azure and where it began, well, it started using Windows Server and using Hyper-V for our virtualization. And if you look at the next slide here, we have scalability. And if you look at what we did in Windows Server 2000, 2012 R2, it's funny, I remember when we did 2012, and I remember we were working on 2012 R2, and I remember talking to customers, and I said, so are these numbers, how much more do you need? And they were like, no, 4 terabytes, that's plenty. 320 logical processors, no, a terabyte of memory per VM, 64 VPs per VM. We were like, no, we're good. And so with 2012 R2, we didn't make any changes because there was no customer demand. Well, when it was time for Server 2016, again, had the same conversation. And this time, a few of them said, no, we're actually looking at these new and interesting workloads. We're looking at Hackathon and in-memory databases. We're looking at machine learning. We're looking at large, really large scale-up workloads like SAP HANA. And all of a sudden, 4 terabytes actually doesn't look as big as we thought. So guess what? In Server 2016, we said, no problem. What do you need? And in fact, another part of this was also Azure. Azure came to us and said, look, we are running big workloads. We'll take the biggest, baddest servers you can give us, both physical and virtual.
The destination for every workload in the world.
Yeah.
They don't want any excuse for you to say, I can't run it up in Azure. And guess what? I can't think of a single excuse right now. So up to 24 terabytes per physical server, that's a 6x improvement. Up to 500.
I can't believe that. 24
terabytes.
Terabytes, right? I asked people like,
Terabytes.
hey, how many people have a terabyte disk? Lots of people raise their hands. I said, how many people have a 24 terabyte disk? Nobody raises their hand, right?
It's 24 terabytes of RAM.
RAM.
Yeah.
I just love saying it. It makes my mouth
Oh,
feel
no, I love
good.
it. I totally, trust me, I'm right there with you. 512 logical processors, that's a really big server. Virtual machine memory, yeah, this is crazy. This is a 12x improvement, up to 12 terabytes in a VM. So there is no better way to run SQL Server. There is no better way to run SAP HANA than to do it in a Hyper-V VM and up to 12 terabytes of memory. We got you covered. And then finally, the biggest VMs here, up to 240 virtual processors in a VM. We did 64 last time. Honestly, we didn't have really that many people clamoring for more, but again, Azure was big on this. They said, no, we will absolutely use it. So we said, you got it, sky's the limit for you, 240 virtual processors. And I do want to point that is in both standard and data center. I've had a couple people ask me, do I have to buy the really expensive edition of, do I have to buy data center to get this? And no, this is in standard as well. Other guys may have to buy their super crazy enterprise plus super special, super probation version to get that, but this is in standard and data center. So in addition, we've done a whole bunch of work in clustering and resiliency. ClusterOS rolling upgrades makes it easy to take your 2012 R2 infrastructure on a cluster and actually roll it up, upgrade to 2016 without any downtime for your Hyper-V infrastructure. We're using mixed mode clusters, being able to run 2012 R2 and 2016 in the same cluster nodes so that you can make that cluster, and then when they're all upgraded to 2016, flip a switch, a single PowerShell command, and boom, you're running at the 2016 functional level.
And those two features combined are another reason why when we talk to customers, they're really excited about Windows Server 2016, and particularly the fact that they might be able to adopt it at a faster rate because it doesn't disrupt their current environment, and they're able to bring it in kind of incrementally over time.
Absolutely. Yeah. Anything we can do to ease that transition, that's what we've been working on. And then, of course, VM resiliency. One of the things we want to do, we realize we spend a lot of time working on things in clustering, and a lot of times we assume, oh, storage has gone down or a server has gone down. But sometimes you get that middle ground where you've got a flaky network cable or a flaky storage cable or something like that, and something's coming in and out. And you realize, wait a minute, there's something wrong with this. It's not catastrophic, it hasn't gone away completely, but it keeps coming back. So we've added things around quarantining and things like that to help make sure that we can identify these, notify those folks through health notifications, and do the right things to make sure that we're protecting the workload and protecting the overall cluster. And again, I'm going to keep moving here, but we've also done things, yes, around fault domain aware clusters. Really tremendous work we've done across the board in cluster enhancements. And actually, there's one on here that's not on here, and I have to mention it. I'm super excited about this feature. Load balancing is built into server now.
Yes.
So if you are used to running virtual machines, you got a 4-node cluster, and you just want it to load balance, we do it automatically now. Yep. In the past, this was a feature of System Center in VMM. And it's still in VMM, but for people that were running small configurations, 3 and 4 nodes, it's like, I really want this as well. And so you know what? It's actually in there. It's on by default. So when you deploy a 2016 cluster, we will automatically load balance it for you without you needing to do a thing.
That's awesome. The thing I'd like to highlight on this slide is that what we've done is we're really paying attention to the full life cycle costs of the server. And we're designing the drama out of your server. Hiccups happen. We have anticipated those hiccups, and things just keep on running. So we just want to get the drama out of the system.
Absolutely. Love it. We've also done a whole bunch of things around storage. First one, Storage Replica. We just noted the 10-year anniversary of Hurricane Katrina about a month ago. And Katrina was very much opened a lot of eyes for us around here. We introduced a whole bunch of disaster recovery technologies. We wanted to make it really easy for people to protect their businesses, protect their core assets. We did things like Hyper-V Replica. We've done a ton of integration around with Azure and Azure Site Recovery. So we've got a great storage solution there. What we also wanted to do was make sure that we could extend that further and be able to create things called stretched clusters. So we introduced Storage Replica. Storage Replica allows us to create stretched clusters. And the nice thing about Storage Replica is it works with any type of storage. It could literally be a single server with just spinning disks inside it. It could be a server connected to a SAN. It could be a server connected to a scale-out file server. And it can replicate using our inbox storage replica. So it really creates new, affordable business continuity and disaster recovery solutions in the box for the first time. Storage quality of service allows us to really provide service level agreements and provide policy for virtual machines so that an important VM never gets starved for resources. And then finally, Storage Spaces Direct. This is really the key linchpin around the work that we've been doing in this release to really enable a new class of solution around hyper-converged solutions and converged solutions. And Storage Spaces Direct really is the linchpin to delivering these new types of models. So we have two models here. First one is the on-premises disaggregated solution. In this, you can see we've got one tier of systems for my Hyper-V hosts. This is where I'm running my virtual machines. This is where my memory and CPUs are actually running for the VMs. But the actual storage resides on my scale-out file server. And this is using SMB3. This is just standard Ethernet to communicate with standard servers that are providing the scale-out file server. So Storage Spaces Direct gives me a super high-speed infrastructure way to actually replicate all of my storage and make it really simple and easy to deploy. And one of the nice things about this is taking our learnings from the storage spaces we've delivered in Server 2012 and R2 and married it with the things that we've learned in Azure. If you look at Azure, Azure deploys servers with a whole bunch of storage, and it deploys it in a model very much similar to this architecturally, where we're doing writes to multiple locations at the same time. So if a server literally yanked the power, it's fault tolerant and it keeps continuing right along.
Yeah, you know, this is a great example of where we took the lessons from Azure and we bring them on premise. Here, what we're doing is we're decreasing the cost because we're using more commodity components, using more standardized components, Ethernet versus funky storage fabric, and we're increasing the availability and reliability because of it.
Yes.
That is using the magic of software to give you gold-plated SLAs on pretty common stuff.
Absolutely. And the thing that also is I love about this is, you know, the industry has pretty much decided Ethernet has won. I mean, 10 gig, two 10 gig NICs are standard on the back of a server these days. 40 gig is shipping, 50 gig is close to shipping, 100 gig is actually already being tested. We've been testing 100 gig internally. And the industry as a whole, I know you love saying 24 terabits. I love saying a terabit Ethernet. The industry is already talking about how do we get to terabit Ethernet? That's like mind-blowing network performance. Well, that tells me Ethernet has, you know, sky's the limit. We are making, as an industry, we are making major investments in that going forward. And you don't necessarily see that in a whole bunch of the other proprietary storage technologies. We think that Ethernet has the long-term solution, which is why we made a ton of our investments around SMB3 and Ethernet. Yeah. That said, if someone still has a fiber channel SAN, they still want to use those, guess what? We can plug right into a fiber channel SAN. We're plug into your, you know, your traditional NAS appliances. We work right there as well. So we have solutions for all of your storage, but this is definitely a new additive solution.
And as I've been saying for a number of years, make sure when you buy a server, the NIC supports RDMA.
Yes.
RDMA is the thing that makes SMB3 just rock. Exactly.
Which takes us to, of course, this new way that we're also going to be delivering solutions, which is through hyperconverged. Now, hyperconverged looks very similar to what we had on the left, except in this case, you have 4 servers, and those servers are running both the storage and compute simultaneously. And this is why RDMA, Jeffrey's so adamant, I'm adamant about this as well. You really should absolutely be using RDMA. And the reason why is this. In a hyperconverged solution, just a simple 4-node solution, when your VMs are working, it means that the CPU is also having to manage and replicate all of that storage across all of those servers. which means on a 10 gigabit Ethernet, it actually can consume about 2 cores on a modern day processor, which all of a sudden, if those VMs get really, really busy and there's a lot of storage, it can start to consume more and more CPU and affect your overall scalability and your overall density from the amount of virtual machines you can run. With RDMA, we can actually deliver this spectacular performance with little to no CPU overhead, which means it doesn't impact your overall scalability and it doesn't impact your overall density, giving you the best solution for hyperconverged solutions. So with that, let me give you a demo and let's take a look at software-defined storage. Cool. I'm going to pass it on over to Cosmos Darwin to demonstrate software-defined storage.
Hi. I'm Cosmos Darwin. I'm a program manager on the high availability and storage team at Microsoft. Let's take a look at Storage Spaces Direct, one of the exciting new features coming in Windows Server 2016. Spaces Direct is software-defined, shared nothing storage. That's a mouthful. So let's look at a demo to see what this means. We're going to start with just 3 industry standard servers with internal drives. I want to emphasize that there is no shared storage here, there are no fancy cables, it's just Ethernet connecting 3 servers. And if I remote desktop into one of those machines, I can actually enumerate the physical disks in that machine and see that there are 6 of them, the 4 hard drives and 2 flash devices. That's it, just local drives. First, let's make a cluster out of these 3 servers. This will allow them to work together to provide things like high availability. We'll run the new cluster command, listing off those 3 nodes, and you'll see it just takes a moment to run. We'll form the cluster, and there we have our cluster called demo, and if we enumerate the nodes in this cluster, you'll see that there are 3 of them. There they are, 1, 2, 3. Great. This is where the magic really starts. Storage Spaces Direct is going to take the internal drives from these servers and create a software-defined pool of storage that is accessible to all of the machines. This pool will have cache, tiers, resiliency, erasure coding across columns, all the things you would expect out of a high-end storage solution configured automatically. To do this, we're going to run the Enable Cluster Storage Spaces Direct command. This can take a short time to run. We'll click Yes and let it go. And just like that, we've enabled Storage Spaces Direct. And if we take a look at the storage pool, we now see all of the drives from all 3 nodes. And now we're ready to create volumes into which we can put whatever data we want. To do that, we'll run the new volume command. Here I'll run it in a loop just to create a bunch of them. You'll see how quickly this goes. So there I've created 1, 2 volumes. There's a 3rd one. Now something to note here is that these volumes are running the cluster shared volume file system. This means that the volumes will look to each node like they're mounted locally. More than that, these volumes have another interesting property. They have built-in fault tolerance, so that if drives fail, or even if an entire node goes offline, all data stays online and accessible. This means Storage Spaces Direct works great as a scale-out file server, or in a hyper-converged configuration where virtual machines sit directly on top of the volumes. And if we need to scale out, all we have to do is add another node to the cluster. We can do that by running the add cluster node command. The node will take a moment to join, and then we can run the get cluster node command to see that indeed we now have a 4th node in our cluster. And if we go very quickly, we can enumerate the physical disks which are not yet in a pool and see the drives that are in this node we just added. However, over time, without any additional steps, Storage Spaces Direct will absorb those new drives and redistribute the volumes to take maximum advantage of all of the available storage. And this entire process of starting with just regular servers, creating a cluster, forming a pool of software-defined shared storage, creating volumes, and then scaling out took less than 15 minutes of real-world time. But Spaces Direct isn't just easy to deploy. It's also fantastically performant. The storage pool will automatically use the fastest media present to provide a built-in and always-on cache. For example, here I am on a different 4-node cluster. It's still just 4 nodes, but it's a little larger. It's got a few more devices. We can see here, there are the 4 nodes, and in each node, I have 4 NVMe SSDs and then a bunch of rotational spinning hard drive disks. This is not an all-flash cluster. I'm using an open source tool called VM Fleet to deploy no fewer than 80 virtual machines onto these 4 nodes. And those VMs running full tilt are getting over 1 million IOPS from these 4 nodes that are not even all flash. That's not bad for a feature that is included at no additional cost in Windows Server 2016.
That was great, Cosmos. Thank you very much. So that was software-defined storage. Lastly, I got to make sure that I give a nod to the work that we're doing in software-defined networking. And this probably is one of our unsung hero features in this release. If you look at what we've been doing in Azure for the last many, many years, if you look at what we do, I've had a lot of people come up to me and say, Jeff, when I go up to Azure, I see you've got software load balancers, distributed firewalls, you've got network controllers, you've got all sorts of these crazy awesome features up there. But I noticed that you don't have those in Windows Server. Is this your way to try and kind of force me up to Azure? And my answer's always been, no, we just haven't had the opportunity to bring that technology on premises. We've had a lot on our plate these days. Well, with Windows Server 2016, we're doing exactly that. We are bringing the Azure data plane. The same exact data plane running in Azure is actually coming on premises in Windows Server 2016. On top of that, we're bringing a network controller, enhanced network security, and we're about reducing costs. A couple things I want to point out. I could spend pretty much an hour just talking about the content here, but one thing I wanted to point out here in the first column, VXLAN-based virtual networking. In the past couple of releases, we've supported NVGRE. There's also VXLAN. There's also a couple of different ones out there. Look, the important thing is we want people using network virtualization. Honestly, I don't want this to become a Betamax versus VHS type of war that we had long, long ago. So we're actually going to support both NVGRE and VXLAN. So if you're using VXLAN, great, guess what? We can just integrate and it all just works. If you're already using NVGRE and you want to keep using NVGRE, great. All of our stuff just continues to work. The important thing is that you're adopting network virtualization because it can do things like the next column, which is enhancing network security. With a distributed firewall, with micro-segmentation just simply built in and part of the platform, it allows me to secure my infrastructure and do it in a very logical and easy way. So these are a bunch of things we're doing here. And then finally, when you get to reducing costs, it's about providing predictable performance. So we spend a lot of time working on quality of service, both in storage, but also in networking. Also making it easier to do monitoring and automation to reduce OpEx. So, really it's a huge area, software-defined networking. But again, a big part I want to point out is we're bringing a ton of learnings from Azure down to on-premises in what we're delivering in Windows Server 2016. And I very much invite people to start taking a look, start deploying software-defined networking, and really understand the massive investment that's being made that can help here in enhancing your network security. So with that, I'm going to pass it back to you, Erin.
Sounds good. And so, we're in the home stretch here, and we talked a lot about investments that we've made in the infrastructure, but it's really important to step back and say, well, why do we have infrastructure in the first place, right?
Right.
Nobody told me that they wanted to stand up a server just to stand up a server, right? That really is about supporting the business and supporting the innovation that happens on top, which is really in the developer and the application or workload space. And so if we think about supporting information, it doesn't matter what industry that you're in, right? The fact that, every person now, pretty much has a smart device in there that travels with them that they have access to has just transformed, the way in which businesses need to do business. So whether or not you're in travel and transportation and healthcare and banking, entertainment, right? You want to have that connection with your user and develop that loyal fan base. And you do that through applications and services that you do to kind of promote your business and stay connected with the customers. No industry is immune to this. And so it really is something that we really see helping to kind of propel that inflection point or then transition to the cloud is how do we take advantage of that? And at the root of that is really the application. And so if we look at the investments we've made in Windows Server 2016, we kind of, there's kind of different classifications, right? There's first, how do you start with the applications you have? And so how do we think about running existing apps with more security and thinking about a lot of the work that we're doing in security at the infrastructure layer, but then extending that up into the application space. The second piece of this is about how do we evolve existing apps with new technologies? How do we take advantage of the new DevOps style of workflow and the way in which developers want to interact and build and interact with their infrastructure, interact with IT, and develop their applications and help them with new technologies like containers, like a lightweight operating system, like desired state configuration to really help them automate that DevOps workflow. And then lastly, how do we help them create and innovate cloud-native applications, taking advantage of new concepts such as microservices in order to really have an agile application and an application framework that they can use to develop and get kind of the goodness of what they have out to their end users and keep pace with what the demands are of their user base. So just like, Jeffrey, you talked about on the server side of things, and we've been through this, set of eras and this transformation of what's happening on the server, the application space is going through a similar transition, right? From legacy applications, if you think about it in that enterprise era, we would have these big monolithic applications that, really be like, you want to deploy the application, give me a new server for that, right? And so that really, in some sense, fueled a lot of what we were doing in the IT and in the infrastructure space. But as you think about the transition to cloud-native applications and microservices, it's a completely different architecture that you really need to be concerned with. And so I wonder if you could share a few thoughts on just, what we, is kind of at the forefront of this new transition.
Sure, microservices are the rage. And so the question is why? And at the heart, you hear lots of answers, but from an architect's point of view, the heart of it is environmental decoupling, right? So basically in the past, we would have this environmental coupling. We take components from different places, and they'd run when we'd integrate them with DLL calls or local RPC calls, all on the same machine. So what that meant is they were either sharing the same environment in terms of the same process or the same environment in terms of the same OS. And then what would happen is, as one component needed some change in that environment, it would affect the other components and affect
drag them all along.
Yeah, or break them. And so what environmental decoupling, it really became enabled by great networking. Okay, because now the networks are so fast and so low latency that you, instead of doing things through local calls, DLL calls, you can integrate these things through protocols. And when you integrate them through protocols, that means they can run in their own environment. Okay, and when they run in their own environment, they can get exactly what they want. They can change it however they want, etc. Now, in order for these things to work through protocols, you have to be more formal about it. So now all of a sudden the contract gets more formal, and you can put a software load balancer in there. So what that means is now this one component can go from 1 to 2 to 7 to 700 instances, and this guy doesn't have to know about it at all. So too, this guy can say, oh, I've got the latest version of the operating system. Oh, I've decided to rewrite it in a different technology. Once you deal with things through a protocol level instead of a DLL level, it gives everyone the capability of being awesome in and of themselves to meet their full potential and to not be necessarily gated by the other person. And then of course with services, microservices, some of those you're writing yourself, and sometimes you're taking advantage of other people's microservices. And often in the cloud, those are stood up by professional teams that are manning them day and night, making sure they're highly available. So basically that core architectural change changes everything.
It allows people to focus on what their expertise is, right? And what it is that their special sauce or they're trying to do. And then, kind of in some sense take a dependency on, other higher quality components as opposed to having to write the whole thing themselves.
Right, and actually you can have different release cycles.
Yeah.
So when they're all in the same thing, if it changes, well, you got to retest all this. But if they're in different environments, he can be changing every hour and he can be changing every day.
And so it goes back to that whole agility and how do we make sure that we're keeping pace with the demands of our customer environment and what we want to do for the business.
Right, in my mind, that is the heart of microservices.
Great, so Jeff, why don't you talk to us about another new investment, new feature that's coming in Windows Server 2016, containers.
Absolutely. So containers have been a large investment for us in this release. And what's interesting is, Containers have been a funny thing. So they've been kind of growing in popularity, and you've been hearing a large chorus of people out on the web telling us how these are the greatest things ever. If you would just adopt containers, your cars will get better gas mileage, your hair will grow back more lustrous than ever, it will solve more problems than ever. And and the other thing I keep hearing is also it's going to kill virtual machines. And virtual machines are, containers are greater than virtual machines, and it becomes this your chocolate's in my peanut butter kind of moment. And I keep going, no, these are actually two different things. Virtualization is great, containers are great, you can actually use the two together, but let's kind of talk about the differences between them. So first of all, with traditional virtual machines, with hardware virtualization, we do exactly that. We actually virtualize hardware. We pretend to have a motherboard and processors and storage and all of those things. And we did this so you can install an operating system, kernel and all, and it would just run, and then you install your applications, and we treat it just like a physical machine. Containers are very different in that way. Containers, you're basically saying, look, I've got a hardware, I've got an OS, but I've also got a kernel. And what I'm really doing is, essentially containers are what we call operating system virtualization, where applications are running and they're all talking to a shared kernel. And you're getting extra sandboxing protection around them. So each app, when an app is talking to the kernel and communicating with the kernel, it thinks it's the only thing that's running on the system. So it doesn't see other applications. So there's better isolation between each of them, but they are sharing a common kernel, which both has pros and cons. When it comes to containers, the interesting thing about them is they do enable this real agility when it comes to releasing new containers. So for example, today, when you install an application, you probably go through an XE or an MSI, and maybe you've got to go through multiple ones of those, and when it's time to update those, you've got to run an updater or a patch or an uninstall and all of those things. With the container, everything is self-contained. So here I have this file that has my XE, my DLLs, my frameworks, everything that I need, and I basically hand this to IT and I say, go run that. And they literally just run a container, and it just goes. And when a new one comes, and maybe it's like literally 30 seconds later, a developer said, whoops, I gave you the wrong version. I gave you version 1. I was supposed to give you version 1.5. IT says, okay, let me turn this off and let me turn on the new one. It's that simple. I didn't have to go through an updater, I didn't have to go through a patch mechanism. So for a lot of people in IT, they tend to almost think of a container as, you know what, this is what's going to replace the installer going forward. And that's not a wrong way to think about it. The important thing is it helps developers with agility, it helps IT with deploying these in agility, and allows me to iterate these on a very quick and fast way.
Probably just a clarification, so people think that it makes the installer go away, but they're actually wrong. We have a new installer, and you still want to use an installer, but the point is that now the installer will be done in the build lab.
Exactly.
And you compose it all there, so you still need installers, but you do it in the build lab instead of the running instance.
Exactly.
You do all that work and then deploy the results.
It's pre-runtime versus at runtime.
Yeah, so when Andrew Mason comes and knocks on your door and says, hey, you got to write to the new installer, you write to the new installer.
Yes. He knows what he's talking about. Now, like I said before, containers, they're sharing a kernel. And this may be fine if this is running in your own infrastructure where you know all the other actors on the same server. But when you talk to compliance and regulatory or folks that work in these highly regulated environments and you say the words shared kernel, I'm going to tell you right now, it doesn't go over very well. I remember talking to a compliance and one of these guys, a compliance officer, and I asked him, what do you think of containers? And he said, oh yeah, we hate those. And I said, what are you talking about? This is the hottest thing ever. And he said, look, we just got over virtualization. We get now that VMs are isolated, they're isolated in hardware, we're good with that. But with containers, you're telling us there's a shared kernel, that gives us a moment of pause. So we said, you know what? We understand that. We said, look, we're not going to try and argue with this. So we actually came up with two types of containers. There's actually a Windows Server container, which has a traditional shared model. This looks very similar to what's going on in the open source space. But there's also a second type of container called a Hyper-V container. And with Hyper-V containers, essentially when you deploy it, this is a runtime option. You actually think about it as checking a checkbox mentally. Is this a Windows Server container or a Hyper-V container? If it's a Hyper-V container, then in fact, I don't share the kernel. I get my own separated kernel. And in fact, we actually put up the Hyper-V shield, so you essentially get a hardware isolated container as well. So the beauty of this is for a developer, you just develop your container the same way you would. Use whatever your tools. Use Docker. We integrate with all of the great Docker tools that are out there that just works with Windows Server and Hyper-V containers. And your developer just develops the containers, but when you deploy it, that's when you determine whether it's going to be a Windows Server container or Hyper-V container. If you're deploying in a public cloud, you're going to want to use Hyper-V containers. If you're deploying on premises, depending on what the workload is, if it's test dev or if it's production, but it's not in a compliance or regulatory, maybe Windows Server containers are great, go use them. If you need that extra level of protection in your enterprise because you've got compliance regulatory concerns, great, just use Hyper-V containers, and it gives you that next layer of isolation.
And it's worth pointing out that each of these Hyper-V containers has their own kernel, but it's a very special version of the Windows Server kernel, highly optimized for this scenario.
That's exactly
so it's
right.
still very fast.
Finally, this takes us to NanoServer. NanoServer is our new installation option and deployment option for Windows Server 2016. We like to think of it as just enough OS. So if you take a look at the right-hand side, you can see we have 3 deployment options. We have the traditional Windows Server with the desktop experience. That's the full enchilada, I like to think of it. It's got roles, it's got features, it's got a GUI, it's got Explorer, it's got browser. That's about 9 gigabytes after you install it fully into a virtual machine. Second one, the middle, we've got Server Core. And Server Core is how we've been telling you for a long time to deploy your server operating system. In a virtual machine, that's about 5 gigabytes on disk. The goal here with Server Core is to really get people to do remote management. While it still has all of the roles and features, still has the WoW layer for 32-bit support and all of those things, but it does require, it has no GUI, so it does require that you manage this thing remotely. Finally, we're taking this to a new level with NanoServer. NanoServer is about 480 megabytes fully installed in a virtual machine. It's much, much smaller, and this is an optimized 64-bit kernel. This has no roles or features included in it. Of course, you add those afterwards. So really, NanoServer has 2 ideal ways to think about deploying it. Number 1, of course, in a container or in a virtual machine for your next generation application. As you start writing with .NET Core or Node.js or using the mean stack or any of those types of things, NanoServer is the optimal way to do that, whether you're doing it in a container or in a virtual machine. The other way to think about it is using NanoServer on the metal itself. So if you want to deploy NanoServer and then apply the Hyper-V bits, you have the most optimal Hyper-V server because in fact it reduces the attack surface, and thus servicing goes down, of course, dramatically with that as well because it's literally just the kernel and just the Hyper-V bits. Hyper-V is one example, IIS is another, and of course the scale-out file server means you can use it as well for that for the scale-out file server. We've integrated with Windows with Visual Studio. So for example, as you develop your next generation applications and as you're deploying to NanoServer, we'll actually make sure and give you some visual assistance to let you know when you're trying to use functions that may or may not be available in NanoServer, and we want to make sure it's really easy to develop and deploy new applications in Windows Server containers using NanoServer. So with that, let's move to one of our customers who's actually using Windows Server containers today and actually deploying it in production to modernize their infrastructure.
Tyco Security Products is focused on life safety. So we have access control, video surveillance, intrusion, and fire suppression systems. Tyco focuses on the solution of integrating all of these together.
I've been involved with taking our monolith, our legacy application, and helping understand how we can modernize it, move it into the cloud, make it more elastic. Before learning about Windows Server containers with Docker, we were using virtual machines. They're kind of cumbersome, and there are a number of challenges to using virtual machines to achieve elasticities.
We're all working on a solution that's very tightly coupled. So if you make a change in this place, you didn't really know, but it broke somewhere else. Go into more of a microservice architecture and a container-based solution where each component owns its own data. As long as you don't change the APIs, you can make changes within that one component and you know you're not going to break anything else.
The Windows Server container solution made life very easy for our team because our application just worked when we put it there. By using Windows Server containers, we'll be able to modernize our architecture and deliver our customers superior access and video products. Using Windows containers will allow us to achieve greater high availability characteristics, truer elasticity, and to push updates to the customers faster, and to deploy those updates with minimal or zero downtime. Additionally, it's allowed us to begin automating our pipeline from development through QA, through production. And we see a lot of efficiencies that we're going to gain as we further automate that pipeline. Windows Server 2016 with Docker has first-class support for the .NET apps, and it ran very easily.
With containers, we've been able to deploy 1,000 containers and be able to simulate things that we were never able to simulate before. We can scale our mission-critical systems much more efficiently so that we can support more devices. With a security platform that manages life safety, you can't be down. Windows Server and the container technology in general are going to help us fulfill our requirements of being able to react to life safety events in real time.
Thanks, Jeff. That was a great customer video showing how they're able to take advantage of Windows Server 2016 and get the benefits. So, we talked today about the evolution of Windows Server, and I wanted to highlight that Windows Server 2016 is great for the cloud, but it's also great for those other areas, right? It's a great enterprise server, it's a great data center server, and it's a great server for the masses. These are additive solutions. It doesn't have to be a choice. Aaron talked to you about how customers asked us to help them with their 3 primary areas of concern: securing against threats, saving data center costs, and in driving their business forward through application innovation. And we've shown you how Windows Server 2016 delivers great modernization in each of these areas. Of course, Windows Server System Center is our management platform. It is the thing that completes Windows Server to deliver an integrated solution for you. So go to the link here. You will get documentation, demos, and an evaluation copy. And we are very customer focused. We do all this work for you. So please give us feedback on your experiences with Windows Server 2016. Let us know where it's working for you. Let us know where we have some additional work to do. And again, thanks.